Is it online?
Yeah, I think it's open. If you are, let's see, what's the time now? Yeah, I mean, just give a minute and then you can start.
Okay, I think we'll wait for a minute. Yeah.
Yeah.
I'm just going outside the slides here. Just check the numbers are there. We don't see the numbers here, no? Or we see the numbers? We have 31 participants.
Just a few more seconds. Yeah, I think we can get started, and people will join in. Let's get started.
Okay. Yeah, Rajesh, you can take the first slide and go ahead with this. Yeah.
Sure. Yes.
Yeah.
So we have welcome everyone. Thank you for joining this call. So this is Informs has a webinar series on applied analytics. So we host a number of seminars, and this particular, we also have a series which focuses a little bit on Indian speakers and Indian audience. So this particular webinar is a joint initiative of the Informs practice section and the ORSI Ahmedabad chapter. Is Sundrawali on to?
No, I don't think she has, possibly she has a meeting and other. I think she.
So Gautam, if you want to introduce yourself for a second.
Yeah. Yeah, I am Professor Gautam Datta, retired faculty, or in US what is called post-tenure faculty of IIM Ahmedabad. And I also have a visiting appointment in Indian Institute of Management, Mumbai. And few days back, Rajesh was telling that why India is absent in Edelman Award and other. So I said that it will take some time, but let's start a webinar. So we had one webinar in the month of July, where I think Ramesh, one of the faculty in IIM Mumbai, spoke about his work in gas distribution. So today is the second one. We should have done a little earlier, but it is about Indian Railways seat capacity allocation related to revenue management. And I would give it back again to this. I think that's what we are planning to do. We would like to have at least 3 to 4 seminars once in every quarter or whenever the speaker is ready to speak about anything. So we would like to go it on an ongoing basis so that whoever is doing anything, it is put into a platform. So we are just opening a platform. There's no commitment. It is completely a pro bono publico effort between the ORSI Ahmedabad chapter and the Informs group of applied analytics or Informs practice group. So we hope to continue with this. And later on, we also plan to have, if we get sufficient numbers within India, some practice prize competition, which we did for 2 years when I was the president of ORSI. That's not happening, but we want to restart that. So that's what we have now. I think I'll hand it over to Rajesh to speak about a little more about that Informs to the Indian audiences. Maybe we should have said good morning and good evening to both the audiences in India and the US. Anyway, good morning and good evening. And so hand it over to Rajesh.
Yeah, thank you, Gautam. So again, I'm Rajesh Tyagi, currently the president of Informs practice section. I think for the past 2 years, I worked a lot. I hosted a number of webinars, most of which were focused primarily on US speakers and audience. And then Gautam and I started talking about it and wanted to have certain webinars focused on Indian audience as well. If you can go to the next slide, please, Gautam.
Yes.
So I'll take a minute and talk about the practice section. So the purpose of the practice section, or the formally called the Inform section on practice, is to support the practice of analytics among analytics and OR and management science professionals. And to that end, we hold 3 major competitions. So we have the Franz Edelman Award, which actually the finals will take place in 2 weeks' time in the middle of April in Orlando. And if you Google 2024 Edelman finalist, you will see a little bit of information on all the 6 finalists, and Tata Steel is one of the finalists this year as well. We have the Daniel H. Wagner Prize, and we have the UPS George D. Smith Prize. We also hold some monthly events. So these are these applied analytics webinars, whether from India or from the USA. And we also have a monthly virtual networking happy hour. We talk about different, very informal session. We try to get some panel together and talk about different topics there. We also have some events related to conference. We have a practice session track, which is offered during the Inform's annual meeting in the fall. This is where we have 5 or 6 sessions which are totally dedicated to practical applications of OR and analytics. And we also distribute a section newsletter. And before I hand it back to Gautam, I just wanted to say, hey, to the audience, if you have any suggestions about certain speakers or know of somebody who would like to make a presentation, please let Gautam or myself know. And also, if you have any suggestions on how to publicize these events to the Indian practitioners, are there certain groups or certain universities? How do we reach out to them? If you have certain suggestions, please do reach out to me or Gautam. Thank you, Gautam. Take over, please.
Thank you, Rajesh. So we have a core group here who is myself, Sanjay Kumar Prasad, who is the chief data analyst and a distinguished practitioners of OR and analytics in IBM India. And Siddhartha Sengupta is an ex-TCS person, Tata Consulting Services. And he is also a faculty in IIT Mumbai, or ex-faculty of IIT Mumbai. Sundaraballi is a faculty of IIM Ahmedabad, and Sumita, she is a faculty in Nirma School of Management. So we had 2 practice prize competition within India when I was the president of ORSI, and after that COVID started, so this got. So we'd like to start this again every year. I think there is still a practice applications paper contest in ORSI which goes on. So this is more or less work which is going on in India. I think practice is going on, but I think publications of the practice or sharing of the information of the practice is not happening. So that is the reason we started this competition to bring or encourage people to do this. And we are going to have today Dr. Gopalakrishnan, General Manager, Data Analytics, Center of Railway Information System in Indian Railways. And he is going to speak about ideal train profile capacity allocation tools for the reserve passenger segments for Indian Railways. Long years back, I also did work with Indian Railways under the faculty of IIM Ahmedabad and looking into their revenue management aspects. But after that, their group is currently working on the last 10 years or so, and they have done good amount of work. Revenue management has been implemented in several of the trains in the reserve segments. I think he's going to speak about that. Within a few minutes, I'm going to hand over. Again, I'm going to ask to you that if you have any suggestions to sharing of information about the practice, so please let me know, let Rajesh know or let Sundaraballi know, so that we can actually take this little forward and make practice group more vibrant within India. It is there, but it needs to be more vibrant, more interactive, so that we should know what we would like to do. So it is better that if you have something, if you want to present, let me know about this. We'll talk to you and figure it out how to make you present this. Now I'm going to hand over to Dr. Al Gopalakrishnan. He is a PhD in OR and analytics, and he has, I think, some appointments in the MIT also. So with this, I'm going to hand it over to Dr. Gopalakrishnan. So yeah, so Dr. Gopalakrishnan, you can take over, and Beth can please hand over this this control to, so that he can do that. Yeah, Dr. Gopalakrishnan.
Thank you, Professor Gautam, and good morning, everybody, and good evening, everybody, depending on where you are logged in from. Is my screen visible to you?
Yeah, it's visible to me.
Yeah, and if I can just interject
Yeah.
for 1 second, again, for the audience, there will be no questions during the presentation, but there is a
Okay,
Q&A
yeah.
button there. Please type in your question there, and Dr. Gopalakrishnan will address your answers at the questions at the end of the talk. Thank you.
Yeah, so I'll be talking about capacity management on long distance trains on Indian Railways. Our group has been working on it for quite a while now. And I'll just give a brief background of what this presentation will basically, we'll talk about what the history of the Center for Railway Information Systems is. It's the IT arm of Indian Railways, which set up in around 35 years ago, 37 years ago. Primarily to start with railway ticketing and computerizing it. Now maintains a lot of IT projects for railways and over 1,900 employees of the company. And we have different applications for varying from traffic control to freight operations to crew management to ticketing and now revenue management as well. All of it has been developed, a lot of it has been developed in-house, and we maintain the IT backbone for railways. And these are a few of the applications that we do as the organization. Primarily, the flagship started with the passenger reservation system, which we call as PRS. The UTS includes the unreserved ticketing system, and we primarily sell around 80% of the tickets through the Indian Railway Catering and Tourism Corporation. That's the website on which most of the tickets get sold. And other than that, there are, as the railways is complex, a lot of infrastructure and rolling stock and fleet management and traffic control kind of IT systems. All of it is being handled by Center for Railway Information Systems. As far as the data analytics unit is there, it's a recent journey. It's a fledgling unit, probably around 5 years to complete. Primarily driven by in-house efforts, a small group of PhD and masters people together and housed in the IT arm. And we are obviously expanding it also so that we are able to take more and more problems related not just operations research, but also in analytics as such, in machine learning and artificial intelligence and things like that. So before I come to the problem, I'll just give you a brief idea of the passenger reservation system as such. It has got around six, or you can say around 7 modules. Basically, one is the client module. Basically, it could be the user interface where you see the booking websites. It could be the Indian Railway Catering IRCTC website or any of the websites which book tickets. They have basic facilities like journey planner and things like that. Then there is a train management section, which is basically related to the capacity management and also the database, what we call as firing, creating multiple profiles of a train based on different demand patterns and trying to optimize the capacities within the train. Then there is a pricing section. Then other things are related to issue of tickets and allocation and things like that. Now, before I come to the use case, I'll just quickly give a background of how the reservation system works. I have a short video demonstration, so I'll switch over to a video. Just a second.
Training on ideal train profile utility. Long waiting list for tickets has been a perennial issue for both passengers and Indian Railways. If
Gopal,
passengers
we can
cannot
hear,
get a
but we can't see any video.
ticket at the time of booking,
Can you
Yeah.
see a
they
video?
start
Okay,
looking
just a
for
second.
No,
other
you have
modes of
to put it
transport.
on the
To address
going.
the
Yeah.
concern and reduce the number of
Is it visible
waitlisted
now?
tickets, they start looking
No,
for
No,
other
I
only
think
modes
it
yours.
is
of
not. Only the train. Yeah.
address the concern and
The
reduce the
audio is
number of
there and just the
waitlisted
slide is
tickets
there.
at the time of booking.
You have to attach that
Introducing
video
Ideal Train
from the
Profile
Zoom.
Utility, a one-stop solution to bring in the paradigm shift in the entire process of optimizing.
Just 1 second. Sorry.
No, that's okay.
Visible now?
Yeah,
Train
Yes.
profile.
thank you.
Introducing Ideal Train Profile Utility, a one-stop solution to bring in the paradigm shift in the entire process of optimizing the train profiling and ensure better results. The video has 5 sections to help you understand the utility better. Concepts of remote stations and quota allocation. different demand scenarios, and when should ITP be used. Challenges faced by PPM cell. Demo of ITP utility. Interpreting the results and outcome of the utility. Concept of remote stations and quota allocation. Let's take an example of Mumbai to New Delhi Rajdhani Express number 12951 that halts at 6 stations. In this train with just 6 intermediate halts, there are 28 different station-to-station tickets that can be issued in each of the 3 classes, a total of 84 ticket combinations. Each combination witnesses variable demand. Shorter distance passengers invariably will have more choices of train compared to long distance passengers. If we allocate tickets on a first come first served basis, a short distance ticket on a long distance train may create a large number of partially vacant berths. So we need to set a limit on number of berths for different ticket combinations. In the example of Surat Vadodara demand, 2 or more additional partially vacant seats are created. One physical seat may create a virtual capacity of 3 or more. Demand might not be there for all 28 combinations, so if we allot seats for each combination, some may go unutilized. We solve this by earmarking remote stations among the intermediate halts. Traditionally, quotas have been assigned only from source to destination, source to remote, and remote to destination. However, the PRS passenger reservation system permits remote to remote quotas to be defined, which allows the same physical seat to be used multiple times, thus providing confirmed accommodation for the different ticket combinations. The ITP utility suggests remote locations based on a combination of distance to weighted inward and outward traffic. Outward traffic is given a higher weightage in the first half of the train journey, with inward traffic given proportionately higher weightage in the latter half of the train journey. Choosing appropriate remote stations is essential, as the reservation is usually opened for passengers 120 days before train departure. Profile changes, such as changing the remotes, are not allowed in that period, and a mismatch in the demand and quota allocated will create situations of waitlisted tickets or part vacant berths. There are many types of quotas. Some of them are primary, sub or second level pooled. Primary quotas are special quotas that cater to station demand. Second level quotas are sub-quotas like the Gulf, defense, ladies, high officials, senior citizens, on-duty staff, specially abled, etc. These are subset of the overall travel demand between any 2 stations on the train. The ITP utility only provides an indication of the spatial quotas required to meet the demand. Subset second level quotas are to be handled manually. Pooled quota is available for most station to station combinations on a first come first served basis when the corresponding station to station quota is exhausted or not available. The ITP utility sets aside the pool quota and provides spatial optimization only for the remaining berths. Different types of demand scenarios and when should ITP be used. Overnight trains such as Lucknow Mail, Gujarat Mail, etc., where demand is primarily between train source and train destination only and thus not in need of remotes, do not need ITP. If there is slight, significant, or substantial intermediate traffic in the route and we decide to have a remote station for the train, ITP can be used to provide suitably optimized seat allocations for different trains, classes, and objectives. All these are the factors and concepts that help define the processes of train profiling followed in PPM cell. Challenges of PPM cell. Different applications are used for getting different reports required to analyze the performance of a train. The process is very cumbersome as the team then has to analyze multiple reports and perform manual calculations. Also, if further changes are to be done because of new suggestions, they have to redo the entire process from the beginning. Ideal Train Profile Utility is a one-stop solution, which is a decision support system based on data analysis. With ITP in place, profiling of trains become easier. Longer trains with lots of stations will have an accurate and impartial analysis. Lots of stations will have an accurate and impartial analysis on demand, selection of remote stations, and spatial quota allocation of seats will be easier and supported with automated trend analysis.
So this is a short video which I thought it gives a background of what the presentation is all about. So I'll quickly go back to the uh, presentation. Is my screen visible? Not yet, right?
No, it isn't.
Not yet. Have you started sharing? Gautam Kar, you still
No,
not?
not yet. Not yet. I think not yet. The screen sharing has not yet started. Yeah, I think it is. Over to
Just
Gopal.
give me a minute.
Ah.
Gopal, are you still connected?
I'm there. I'm there. Just give me a minute.
Sure, we can hear you now.
Mhm.
Probably I'll quickly. Yeah. Is screen visible?
Uh, yeah, it's there now.
I think screen is
Yeah.
visible.
So
Business
basic
is showing
problem that we
business
were trying
problem.
to
Yeah,
address here.
continue.
Yeah. Yeah. The
Yeah,
basic
continue,
problem
please.
that we were trying to address. Yeah. Yeah. So the basic problem that we were trying to address here was that there were a lot of seats which were vacant because of the mismatch in demand and capacity that was allocated to different origin destination pairs, and that led to what we in railways we call it as waitlisted ticket, because there is a capacity mismatch and you put in the queue that only when cancellations happen you get a ticket. But when you board the train, there is obviously find a lot of seats are vacant. So this mismatch was a very perpetual problem. It was very difficult to analyze. It is similar to basically an assortment optimization problem where you have a shelf size which is fixed. For example, in a train we run with 24 coaches, the number of seats that we can attach on a train are fixed. But the issue comes, how do you allocate the different commodities or the different demands for different commodities or origin destination pairs within the seat capacity, because the train has multiple halts. And even a small train which is normally which has got say 4 halts, you've got around 6 OD pairs. And a typical train on Indian Railways will have up to 60 halts, 4 classes, and 365 days a year. We're looking at around 2.5 million probably combinations or demand forecasts that are there. And this is, and we run around 4,000 trains. So we're looking at around a huge number, probably a billion plus OD demand combinations. It is not possible to manually handle those capacity problems. So in one of the earlier implementations that we had, we saw around a 3 to 5% increase in the passengers that we could carry in a train. So the more trains or more passengers for the same seat, and ranging from, depending on how much spare capacity was available, 5 to 25% increase in revenues. So we got around 100 crores. 100 crores is around a billion rupees. In terms of dollars, it could be around probably $10 million,
10
$12
million
million,
plus. Yeah.
$12 million in just one zonal railway. Indian Railways has 16 such zones. we're looking at a potential bottom line or a bottom line increase of around $300 million. So the challenge that comes with around, say, if a train has 60 halts, the number of OD combinations are around 1770. This one is 10 seats. So we can't just offer even one seat to every commodity. It's not possible. So what we do in railways is to try to pool the demand, because there are some demands are very low. We try to pool them together, and that's where the concept of remote station comes in. And all of those places, all of the multiple OD pairs which are close by get clusters and come towards at the remote locations. And what are these remote stations? Where should the remote stations be? It's a difficult question that was we had to answer, and that's where we use things like the centrality algorithms that are prevalent in, say, Twitter feeds, or even in COVID, the super spreader and things like that. So we used basically centrality algorithm. We could have used a number of maybe a binary variable to do that, but it would have made the problem much more complex, because each station in the halt, maybe any of the 60 halts could be a remote location. There are 2 to the power 60 possible combinations of remote stations, so it becomes mathematically a lot of interaction. We used what is common centrality, we find which is the most important node in a network, and that concept used because we in our software we didn't want entire software to be now to change, and that's where the concept of remote stations came in. And what we could do was to determine we have a demand forecasting pair for every journey date. Then there is a remote location module which gives us, based on the demand pattern that is observed on a train, optimization of seat capacity for different OD pairs, and that there could potentially two primary what is called scenarios. One where we have surplus capacity. There is no much of a problem there. Very few trains have surplus capacity on Indian Railways. You could directly go for, say, a revenue maximization kind of stuff. But when we have, say, demand far exceeding capacity, and Indian Railways as because of its more of public social applications and things like that, we have a fixed price regime. There are dynamic pricing, but that's limited to a few trains and a few seats that we operate dynamic pricing on. So we have to do some kind of rationing. So what should be the method of rationing that we need to adopt? So that we left it to the basically this is a decision support system. We left it to the revenue manager for that matter, because they are people who are more aware of their demand patterns across the country. You can't have it at a central location. So you had preference for short distances, either preference for long distances, or you want to be fair to every OD demand that you see. Maybe I want to meet 70% of the demand for every origin destination combination that I have there. And also things like different classes. For example, there are multiple classes, as we saw in the video. The first AC and second AC are the premium classes on Indian Railways. The fares are almost comparable with airfares. And there, because of the trains are definitely much slower than air, so we witness a lot of short distance travel on those kind of segments. And in the what is called a non-air conditioned sleeper class that we have, which is the primarily used by the common man in India, there it's primarily long distance, because they are people who cannot afford an air travel. So if you want to do that, so we have to give in, say, kind of, it's not a one train, we have one optimization kind of a decision support. We didn't have one objective function for, in fact, different classes have different objective functions, and they could change with seasons also. For example, if it's Christmas season, everybody's going back home for vacation, so we would probably give preference for long distances during that time, because short distance passengers definitely have much more options like buses, or maybe they will use their own personal cars, or maybe hire a pool taxi and go back home. But for long distances, there is only two options primarily, either rail or air, and a lot of people can't afford air, so we had to give for long distances. So these were considerations which we evolved. So normally in a typical what you call, we will have an objective function, and then we have constraints, and we'll say, okay, we'll maximize revenues. But those things we could not do it. And at some places there is a lot of feedback coming from the revenue manager saying that what you are suggesting as a result is not what we would like to do, because your results are, because as any simplex method will do, it will stop at the first place where there's no cost, reducing cost direction. So it will stop at that particular point. So you don't actually explore all the optimality solutions. So that's why we had to give in multiple objective conditions. It could be either preference for short distances or long distances. And short distance is the same as revenue maximization in our term, because as is normally in most of the railways, they have what is called a telescopic fare structure. You pay less per kilometer as the distance increases. And because short distance you pay more per kilometer, if you just use revenue maximization, it will tend to prefer the demand for short distances. And as far as preference for long distances is concerned, we use some kind of a polynomial kind of an exponent for the number of passenger kilometers that were there. So the objective function was changed. And in fairness, we looked at some kind of a proportion of every certain percentage has to be mixed, which was again part of the objective function, that we would try to maximize that percentage. Maybe 70-80% of every demand needs to be met. So that's the kind of multiple objective function criteria we had to use. That was something which was a learning for us to ensure that the users accepted our solution. So as I said, these are the methodologies that we added. It's an ensemble of methodologies that we used. Initially, we had used also some kind of neural networks as well in our demand forecasting, but the current module is more of a moving average kind of a demand forecast. We would like to definitely, we're working on improving the demand forecast for things. The reason we had to drop the AI models were because it was taking quite a long time to even churn out those numbers. As I said, there are a billion plus demand forecasts that we need to work on, which we need to compute, and that's not easy for even a normal AI model. So we are still working on that. And remote locations, we're using more of network models and optimization, standard optimization techniques for the capacity allocation decisions. So what we have done so far is we have rolled out this thing in around 2000 plus trains of Indian Railways. Initially, as I said, around the first 2 years or 1.5 years, when we were trying to co-develop with the business users what kind of business requirements they wanted. After 1.5 years, the usage of the decision support system, it was rolled out, but none of the business managers were ready to use it. They said, this is not what we want. And so we had to go back to the drawing board as a product design. There was a lot of product design concepts that we had to look for. We gave a complete digitization platform for them rather than just the OR models probably, and the analysis models contribute around 40% of their requirement of what they do as computation. 60% is still more of a user-driven kind of interactive kind of a dashboard which people will work on. Results in some of the large zones of Indian Railways, we have seen around 10% increase in the time of in the confirmed tickets at the time of booking, because we don't want people to get an unnecessarily waitlist ticket and then they look for other modes of transport. So that we think it's a pretty good result that we got. And we are trying to improve, are working on a version 2 plan as well, where we'd like to look at different fare classes, maybe use some variants of the Littlewood class of models or other models that are in vogue to determine Tatkal quota is like the penultimate day last minute bookings for a business traveler, as we normally look at even in airlines. So we'd like to do that also dynamically, and also a common buffer as we call as pooled quotas, that also we have almost worked on. So we'll probably integrate it with our tool as well. And one must look at the kind of changes that this thing has brought. Earlier, a single train, probably if you want to do it manually, it will take you around 10 to 12 days with an expert in place. And now we are able to complete this exercise probably in an hour or so for every train. So that has increased. That is why the scalability has happened. Earlier, probably you would look at maybe around, at best, with all the teams at different locations of India, we would be looking at 300 to 400 trains, which we could revisit. Now in a single, probably in 3 months, we have been able to do 2000. What we could do 300 in a year, we are now looking at 2000 in a year, in 3 months. So every quarter, probably we can review. So we are now looking at a complete digital transformation of the capacity management, also integration with the ticketing. And as I said, we are also rewriting our ticketing logic to make it more robust and scalable. And obviously, the what analytics can do, or what maybe the capacity management or revenue management is possible, those kind of changes are also will be there, which we would like to work on, and that our team is also working on. So this is what I would like to show as a presentation. I'm open to questions.
Yeah, I think anybody has any question can directly ask Dr. Gopal.
Gopal, if you click on the Q&A, there is one question there.
Just a second.
Gopal, and
Yeah.
if you can't see it, just let me know. I can just
Yeah, I
read out
can
the
see.
question. Okay.
Okay. Did you encounter any degeneracy to be a setback while modeling it as LP or MILP? No, we didn't encounter degeneracy in our solutions. At least because it was a simple enough problem, so we had a more or less a unimodular structure. We didn't encounter any degeneracy.
And if Beth is there, Beth, if you can make unmute all the participants so they can ask any questions directly as well. So Gopal, while we are waiting, yeah. So there's one more question there.
So we use a commercial solver or heuristics. So initially we started coding in open source in Python itself. We used Pyomo and as a library, and we do it pulp library. But now we have shifted to Cplex. Yes, you're absolutely right. Millions of forecasts can be done with cloud. We are in the process of getting that amount of cloud compute, and we are working towards improving our demand forecast. It's important for us because we do have now we have the capacity. The new software will have the capacity to even look for dynamic changes in the capacity allocations during the time when the train is open for booking. And we do have models which are looking at maybe recent demand patterns and arrival rates to make forecasts, maybe updated forecasts for the journey date. But in the initial stuff, we wanted to be as quick as possible. So for initial rollout, we let go the demand forecast model for a while.
Oh,
there's another question. Yeah.
Yeah. So right now, as I said, it's more of moving average for the maybe the same reference period, or maybe it's the Christmas period last year and Christmas period this year. So we have
in the moving average.
Yeah, OCR model.
Yeah, there will be a lag, or whatever you can call it. There will be a lag in the demand and stuff like that. But it made at least our models work faster with the existing compute, and because we didn't want too much effort and IT to be done, because we are using the same IT system which people are comfortable with. It's not a system which has been developed completely ab initio. We had a data warehouse, so it works on top of a data warehouse. So that's the kind of present structure we are working on. And as I said, demand forecast is something which we have models, and we will be deploying it in the next version as well. That's the essence of it, that we realize that the demand forecasting is something which is probably the essence of it. And Siddhartha has one question. Can you explain on why 60% work remains manual? Yeah,
Michael.
Hello, am I audible?
Yeah, we are audible.
Yeah. So Siddharth Sengupta has a question. Can you explain on why about 60% of the work remains manual? So there are some intricate issues, like we have concepts like a common buffer which handles the buffer overflow from multiple OD forecasts or OD demands that we realize, because we can't expect to be 100% correct with our forecast. So whatever overflow happens goes to a common buffer, and how much common buffer to adapt. So these are questions which are more research questions. So we have teams working on that, on how to do it. But till the time, to make sure that we are able to utilize software which works with our software limitations on the ticketing system. We had to do that, and there are also multiple user-specific quotas that we have, which we can say some of them are legacy systems, legacy quotas as well. Like some few seats are reserved for women. There is a system for even for foreign tourists at that time, because that earlier we didn't have probably ticketing systems or online systems, and we have defense quota where we have some tickets reserved for military personnel who travel back to vacation or back to join their work, so we give them priority. So all these quotas are something which are based on, probably say military quota is determined by mutually discussion with the military, with the army or the defense authorities. So those kind of issues are not taken into account in our forecasting models for now. We definitely show the people how much is the utilization, and out of percentage, maybe out of 10 seats, maybe 6 seats got utilized and 4 remain vacant in a defense quota. So that kind of feedback we are giving, so the user is able to accept or reject that kind of decision. But we are not automating that decision as yet. There is still an amount of user accept and reject, because as you transition about the change management, people want some control because they've been used to so much of control on the different parameters or dimensions of the capacity management. So it's a process in which people are getting used to it, and now people are very comfortable with it. So probably the next versions will have more automation, that then maybe it will come down to 20%. So there is a question by Hoshiar Mal about how about is it seasonal data, if I can read it correctly, Hoshiar? Like
Yeah, that
vacation.
sounds like seasonal.
Yeah. So that is again some kind of, because of the dual calendar effect. Every year, probably the weekdays and weekends are not falling on the same days, and you superimpose a Hindu calendar, a Christian calendar, and a Muslim calendar, you're going to face multiple challenges of say the Eid every year shifts to a new calendar of Diwali or holy festivals, which are the most popular festivals in India. That also is not coming the same day. It's not like Christmas, which falls on every day on the 25th of December. So we have models which take the calendar effects as well, as part of a thing like how could there be a long holiday, and whether this is part of the Christmas festival. So obviously we have alternate specific constants which we take into account. So those models are available. We're still in the process of refining them before we deploy them. Then there is a question by Atul Malik: how would the solution work across different types of trains, etc.? Any changes that you are expected due to new generations? Yes. See, in Vande Bharat, which is probably the most premier train that Indian Railways runs these days, it's one of the fastest trains that is available in the system, with facilities similar to, at least the interiors are similar to what the airlines would offer. Some of them have cannibalized. Actually, there is kind of shift from substitution from existing Indian Railways. The people have upgraded themselves to Vande Bharat, and some new demand has come from other modes of travel, like probably could be air and road transport as well. So we don't have models for intermodal travel demand, things like a logit model where we look at what is called different modal combinations or modal patterns for different OD combinations. India is in the process of rolling out its national household travel survey. So we hope to get some amount of data on a large scale from a household travel survey. What's the modal distribution of the origin destination demands for different classes of travel or different modes of travel. In fact, our group has designed the questionnaire. It's about to be rolled out soon. So once that happens, we'll have access to a lot of intermodal data as well, like different modes of data, not intermodal, I'd say different modes of travel. And that could be a good starting point for the first demand estimation. And as and when demand stabilizes on the network, we will obviously use the previous historical demand patterns and try to predict better forecasts. Yeah, see a raised hand by Mr. Raju. Please go
Yeah,
ahead.
this is
Mr.
Raju
Raju.
from. This is Raju. There are certain engineering factors like center of gravity and balancing the entire coach. No, like engineering factors are required while doing the seat allocation. Is that considered as part of this decision variables in the model? That is my question.
Yeah, so there are two parts of this seat because Indian Railways issues seat numbers at the time of booking. It's not like airlines where the airlines allows these days seat choosing the seat, but they also allocate seat at their at the end for those who didn't opt for a seat. But Indian Railways allocates a seat based on certain criteria. It could be like a family of four always gets a seat close together, and those kind of seat mapping is already done, and that's what we call as quota to seat mapping. Like once you decide what the capacity is, then how should the seats be distributed? Because we would like, say there's a too much of rush, we don't want the entire train to get down from two doors of one particular coach. We'll probably like to distribute the demand over 2-3 coaches. That is what we call as distributing the capacity across 2-3 coaches. So this also we are now automating in the process, because as the number of people or the number of passengers in a train increases, the same seat gets used multiple number of times. So there will be more entry exit demand on the doors of the, as I said, more load on the doors of the coaches, which could probably lead to delays caused by passengers not able to get into the train on time. So those things are also we are working on right now. The center of gravity is not a much of a problem in Indian Railways. The coaches are much greater than the human weight. It's
Okay.
normally
Thank
Indian
you. Thank
railway coach is around 46 tons, and the passenger load could be probably 1 ton or maybe 1.5 tons.
Okay, understand. Okay, thank you.
Yeah, the question from Bhaskar Basu. What is the percentage revenue through cancellation? What percent? Through Tatkal? And would like to highlight those.
Yeah, cancellations is in the range of 7 to 10% people cancel, because again waitlist, the more waitlist issue, people tend to book multiple tickets on multiple trains. Like there are 2 tickets on the different classes, same train, or maybe 2 tickets on 2 different trains for the same OD pair, and because they are not sure about whether you're going to get a confirmed ticket or not. So we don't look at cancellations as a stream of revenue for us, except for small amount of 15-20 rupees that we charge for what we call as clerkage, or the booking fee that we have. Tatkal is around 30% of the capacity is reserved for Tatkal. Normally it varies from anywhere between 10 to 30%. So you can see the amount of revenue that we get from Tatkal could be around in the range of 25% of our tickets. Yeah, Siddharth has a question on new trains. That's something which we do by looking at exploring other. This particular capacity management model won't work on it. What we generally do as forecast, for example, Vande Bharat, where should you run a Vande Bharat train the next? We look at things like what is the kind of number of flights for different routes that are available on different websites, and there are some data points which are available publicly as well through the Civil Aviation Authority about the origin destination flows of different airlines. So that's how we decide on which trains to run based on both our demand and what we see as demand which is revealed through other modes of transport. Obviously things like personal cars, trips, and all those things are not available unless we have a household travel survey going on India. And for new trains, initially we tend to be more free with our, we don't tend to be rigid with our capacity limits. We tend to be more free. Maybe that has more pool quota and a first come first serve basis. Obviously we give some seats to important cities, and then as the demand stabilizes, probably 10-15 trips or maybe 30 trips that stabilizes, then we have a serious relook at how the demand should be split, or the capacity should be split, sorry.
There is a question from Mohammed Shahrukh Anjum. What's the size of the matrix and optimization models? And what's the competition like?
Yeah.
what we are able to see as a result in probably 8 to 10 seconds. So the number of variables uh, are manageable. It's not too high for at least this model to look at, because we are only looking at spatial quotas. The moment we look at different fare classes and different user combinations and stuff like that, then it will exponentially increase. And because we are optimizing every class separately, we are not optimizing a train as a train. We are optimizing the 4 different classes that are normally seen on a train as separate models because of business requirements, because somewhere we see more short distance passengers, and somewhere we see long distance passengers. So that helps keeps the size of the matrix smaller, manageable limits.
Hey,
Yeah,
this
Prasad Bhatt.
yeah, there's a Prashant Bhatt here, Dr. Prashant Bhatt. So what will
Yeah.
be the sir, your strategy to choose a best optimizer model, right? There will be different optimizer model we built into the different solvers. So what is the best strategy to finalize the optimization or optimizer model, and what is the best strategy to retrain and fine tune those into the given time domain as the data varies?
Yeah. So what we have seen as from our experience in trains is that the seasonality patterns is quite in a sense quite steep. In the sense, for vacations we definitely would require a different model compared to the lean seasons, say July, August, when schools are reopened in India and more of range, less people are traveling. And as I said, some of the what we have shown as fairness and preference for short distance, long distance, those are different objective function criteria that we have left to the user right now, because we have taken one train at a time. So ideally we would like to take all the trains together and then come up with an optimization model, so that we are able to push or maybe nudge a few passengers not to look for short distance tickets on trains which are meant for long distance passengers, because we have kept them at far higher speeds just to make sure that the long distance passengers are able to reach in a reasonable amount of time. They don't spend too much of time. So right now that particular aspect has been left to the business user.
So Gopal,
Anybody else?
I have one
Yeah.
question. So
Okay.
is all the development done in-house, or are you working with some external companies or universities as well? I mean, you obviously have a whole bunch of projects that you guys have that you work on, and they are in the pipeline.
Yeah, so this particular problem is in-house. This particular solution is in-house, completely in-house, right from the mathematical modeling to user interface. We had to look for product design concepts, and because as I said, the acceptability for the first 2 years was 0, and within 2 years and 6 months it is 2000. So we tweak the product design, the user acceptance changes. We are working on some unsolved problems, as I said, common buffer, pooled quota as a problem. It's now part of a PhD thesis of one of the students at one of the leading business schools in India. So as and when that solution comes in, that will get incorporated into our model. So we are breaking down the model into smaller components, some which are PhD level problems. We have more people working from the universities as well. And because this has to be tailor made with our ticketing system, we don't want to rewrite our ticketing system. We don't use an Amadeus or Sabre, so that it's a standard kind of a ticketing system. We have our own business rules. So this has to be in tune with the business rules that we follow.
Yeah. If nobody has a question, I will just going to ask one or two questions. One is that between the origin and destinations, there is a number of pair of stations which is coming, and that is what you are talking about, these virtual stations and other. So a seat could be occupied by how many virtual station or how many pair of stations?
So right now, what the software which we have, we have around, as I said, there are 14 remotes possible. So a seat could be occupied around 15 times over, the same seat in a train.
Seems to 15
train
times
travel.
such. And if you change
The
that
same seat
15
could be
to
occupied by 15 different passengers.
50 different passengers, 15 different passengers. So which means okay.
15 different passengers, yeah.
And that 15, if you put as a limit, and if you change that limit, does the revenue changes?
It will change. It will change
It will
because
change.
as
Okay.
you allow more people to travel, it will.
Mm-hmm.
This
Okay.
15 is something which we are allowing at the time of booking. So even if there are
Mm-hmm.
some partial seats available in between, that will
Mm-hmm.
get consumed at the time of what we call as charting, where we combine all the quotas or capacity limits together, and we come up with a
Mm-hmm.
compression algorithm which gives maximum number of seats.
And other is that conventional revenue management type of forecastings like additive, multiplicative, and those I think additive forecasting, multiplicative forecasting, and other. Because time series may not be very good, but I figure it out from the earlier work and other. But it will happen possibly if you have a number of forecasting models, and I think use them as a linear combination of normal forecasting model, it becomes a better forecast. That is what we observed in the beginning for only for one trend. It couldn't be generalized. So, what is your experience on using different forecasting model to one forecasting model on this
Yeah,
work?
yeah. So we have traveled. We have tried multiple models, right, from basic time series to Arima to
Mm-hmm.
including seasonality. Then we move
Mm-hmm.
to recurrent neural networks like long-term, short-term memory models.
Mm-hmm.
And what we found out that the LSTM long-term, short-term memory models are probably the best that we could find compared to say traditional econometric models because of the non-linearity that AI can handle. And also the
Okay.
fact that we could look at data points which from the near past, like for example, if I want to predict a demand for say July 31st, my
Mm-hmm.
bookings are already open for say July 20th, 21st, and we are seeing the patterns of booking or arrival rates for the immediate prior dates. We are able to take that also as an input to or of a partial information that is revealed on the arrival rates to make better forecasts for the future.
So July for July 31st, your booking opens will be 4 months ahead of time, na? Which will be
Yeah,
something
yeah,
like
four
March
months ahead of
31st.
time.
And when does the
Yeah,
forecasting
I'm
start?
just giving an
Forecasting
example.
module. So just to, I guess, when does the forecasting?
Forecasting. So we
Yeah.
would like to close our say booking profile by say 127 days before the train starts, so that we have some time for train testing. Like we want to test the train whether the ticketing,
Mm-hmm.
the changes we made have taken into action. So there is some amount of testing that is done. We don't want passenger complaints the same ticket seat got booked twice over. So some amount of testing does happen for each train. So we
Mm-hmm.
like to finish off within before 127 days before the train departure, and we go another 1 week behind that to look at the seat availability of nearby dates of booking that have already opened,
Okay.
and that we are able to use in our AI model, and that we are able to get better results if you normalize that data.
Okay. I think Sanjay Prasad and Samit Viswas has two other questions. Yeah. And Devarajan. So three questions
Yeah,
are pending.
one question is how do you take care of the seasonality? Will you increase the number of trains in some cases by this model?
Uh, Say, for example, we do have a basic model also which looks at whether demand of the train is greater than capacity. Like, for example, if I have 1,000 seats, if I want to fill the entire demand, I know I require 1,500 seats. So we need to convert the passenger demand into coach demand, as then coach demand into train demand. So there is a kind of sequential process that needs to be gone. Where passenger demand gets converted to vehicle demand gets converted into train demand. And those are again models which we are already conceptualized, but again it will take us a year or two to move ahead and deploy. So we already have a roadmap for that.
So I
But
think
right now it is based more on current demand waitlist that we see, that based on that, because obviously at very peak seasons like Diwali or Christmas or
yeah,
Holi,
yeah.
we just don't have enough vehicles or coaches as we call it to cater to all the trains. We will short of crew, we will be short of locomotives to run those trains. So ideally price should clear demand and supply mismatch, and but because of a public service obligation, we are unable to do that.
Excellent. I think this is Devrajan from TVS Motor. Excellent presentation and excellent progress by Indian Railways over the years. How big is your OR team? Is it centralized? What type of review you do and the work is being done?
Yeah, so our team is around 20 now. We'll
Okay.
plan to increase it to around probably 40 by the year end. we're slowly increasing because the challenge is not to get people, the challenge is in mentoring. Because we have to give them domain experience to the, even if it's the data scientists. The domain expertise of railways is something which is very, very, I would say, more niche than the data scientist community. So we need more people who understand railways and railway problems. Then the methodology focus comes in. So, and obviously we are trying to interact with as much academic institutions as possible, so that we have more capacity in the Indian university system, to more understanding within the university system. We are working with around 3-4 IITs, the ISBs, the Indian Institute of Science. So at multiple places we are working on. So it's not just one place.
Gopal, one last question from Sanjay Prasad.
Sanjay,
I think, can you give some examples of PhD level problems that you mentioned?
Yeah, so one of the problems that has been done, and it's in the writing stage, report writing, and this writing stage, and probably will go for publication soon, is on, say, for the pooled quota that we wanted to look at. And that is something, it's like a common buffer, so we had to use value function approximations and things like that in approximate dynamic programming to come up with those solutions. So that's kind of a PhD level problem that we are working on. And similarly, there are other problems particularly related to pricing. Say, if you want to go for the next generation of ticketing systems, will allow us to do dynamic capacity management. So probably we can also have a bid price approach for dynamic pricing, rather than only look at capacity controls. We could have bid accept reject decisions taken based on each individual request that we can do. So that kind of a solution problem is also something which is we would like to work on, but resources constraint that we have, we are unable to take it up for now. Those are potential PhD problems.
So I think we are running out of time now.
Yes,
Any
I
other
think,
questions? Folks can just forward them to Gautam or myself, and we can forward them
Yes.
on to Gopalakrishnan.
Mhm.
Gopal, I just want to thank you. Excellent presentation. I really enjoyed it. Just want to thank you again for taking time out to talk about this problem.
Thank you so much.
So I
And thank
think,
you for giving me
thank
the
you.
opportunity, and thank the audience
you.
also for taking time. Thank you.
Mhm.
Bye-bye.
I think
So much.
anybody has any question, I think can write to me or to Rajesh, or want to give a talk. I think we'll be welcoming that. So it is open thing for you to, if you have a good, you can just give a proposal, and we'll be happy to take your presentation out here. So Rajesh, do you have any point?
Thank you very much. Thank you.
Okay. Thank you very much. I think we'll be closing this now.
Yeah. Thank you.
Thank you. Thank you, Beth.